So for this question, we've got a function, and it looks to me like a quadratic function. Okay, so that's our first thing. So we're already thinking straight away everything we know about quadratics. So first of all, they're symmetrical. That's a key thing about quadratic functions. Now we're told the graph has a minimum value when x equals minus 1.5. Well, the minimum value is always the middle. So this then is the center of symmetry. And we're told the distance between the two zeros of f is 9. So the two zeros are 3 and minus 6. Well, for part A, we know that minus 1.5 is the middle of the zeros. Or in other words, the average. Okay. So what this means, is that this 9, which is the distance between them, if I halve this 9 and add it or subtract it from x, then I'll get my two zeros. So x plus or minus 9 over 2 will give the zeros. So we get minus 1.5. It's been a while since I've done a lesson, so my handwriting's a bit messy here. To get 3, and minus 1.5, subtract 4.5 to get minus 6. Okay, so that's using the fact that the minimum is always the center of symmetry. Now, as soon as I know what some points are, I can always put them into the equation. And that's what they want us to do for part B. So find the value of Q and R. Well, we don't know what it is in this general form, but we do know we can write it using the roots, which is x minus root 1, which is 3, and x minus root 2, which is minus 6. That'll be x plus 6. So remember, we have 3 different ways of writing our function, either the general quadratic form, the factorized form, or the completed square form. Well, if I know that this is the factorized form, if I expand it, I'll get Q and R. So x minus 3, x plus 6 gives us x squared minus 3x plus 6x minus 18. So x squared plus 3x. So we can get from this then that Q is 3 and R is equal to minus 18. Okay. Now question 7. We've got a function f of x. Bear in mind also that these were non-calculator papers. So f of x equals this function and g of x equals this function, and we're given limits on x. The graphs intersect. Now that's our key word here. Intersect means that at some point they are equal to each other. So that's all we have to go on. So all we can do is put them equal to each other and do some rearranging. So we get 3 tan to the 4x plus 2k equals minus tan to the 4x plus 8k tan squared x plus k. Okay. Now let's rearrange it, put it all on one side, because we always do that. If something is equal to 0, we can factorize and solve. So we get 4 tan to the 4x minus 8k tan squared x plus 2k minus another k, so that's going to be plus k equals 0. Now the other bit of information we have is that they intersect at exactly 1 point. So looking at this information, that means that we've got one solution. Now, the only time we refer to the number of solutions is the discriminant. And we know that the discriminant only applies to quadratic functions. So we've got to try and look at this equation as if it were a quadratic. Well, we've got tan squared, tan to the 4, and no tans. So it's like saying, let's say y is equal to tan squared x. So the equation becomes 4y squared minus 8ky plus k equals 0, because tan squared squared gives tan to the 4x. Now, if it's got one solution, we know the discriminant is equal to 0. So delta, which is b squared minus 4ac, equals 0. So putting in b, which is 8k, a, which is 4, and c, which is k, I get that 64k squared minus 4 times 4 times k equals 0. 64k squared minus 16k equals 0, and we can factorize this to get 16k, 4k minus 1 equals 0. So either k equals 0 to make the outside 0, or k equals 1 over 4. And because we're told that k is between 0 and 1, it's just this answer. Okay, so I mean, to sort of, I guess, reassure you, I don't have a mark scheme. I have no idea what the correct answer is. I'm just going from what I see in the question to indicate the method that I would use. So words like intersection tells you what to do. We put them equal to each other. The number of intersections tells you straight away we want it like a quadratic function, so we can use the discriminant and set it equal to 0. If, for example, you didn't see that it was a quadratic function, but you'd noticed that this referred to the discriminant, if you write put the discriminant equal to 0, that would be a mark. So you would get the method mark even if you didn't actually have anything with a discriminant. Okay, Lisa, nothing is a dumb question. I mean, I've struggled on like questions that seem ridiculously easy in the past, and it's just, you need to see it. So the more questions you do, the more exposure you get, the more times you see questions like this, the more you'll notice these tricks that they're using, because there's a limited number of tricks that the maths examiners can use. So let's go on to some higher level maths. Now, technically, this method is standard level. It's a substitution. Standard level students, do not fear. You will not be expected to do this level of integration. Okay, so now when we're doing a substitution, we have 3 steps. We need to substitute 3 different things. First of all, the function. Secondly, the dx. And thirdly, the limits. So standard level, you'll know from an integration by substitution, we typically find the inside part of the composite function, differentiate it to write dx equal to something, and then put those both in, it becomes an easier integral. Now, in case you're interested, high level, it's the same idea, but sometimes they'll give us integrals where it's not easy to see what our substitution is, so they tell us it. So, first of all, we need to substitute the function. Well, that's easy enough. X equals tan theta, we can substitute tan into that. Dx, well, for dx, again, we need to differentiate. So dx by d theta is equal to the derivative of tan, which is going to be, I want to say sec squared, I don't remember off the top of my head. I, truth be told, should have a data booklet open. It's awfully hypocritical of me not having a high-level data booklet on me for this. I tell all of my students to come to every lesson with it printed out. Especially now, make sure that you're using your high-level maths data booklet for absolutely every question you do, because you want to be good at finding where the information is. And it's easiest if you are used to using it. Okay. Come on. Almost there. Okay. So the derivative of tan is sec squared x. Okay. Yes. Oh, Michael, I should have just checked with you. So it's sec squared theta, which means that dx, which is I wanted this as the subject, is equal to sec squared theta d theta. Now, finally, the limits. Well, these are limits in x. So this is like saying between x equals 0 and x equals 1. And I need to find the theta values that sort this for me. So I need to find when tan theta equals 0. And we always pick the lowest value. Well, this is going to be theta equals 0. And when tan theta is equal to 1, you should know this is when theta equals pi by 4. I mean, even if you didn't know that, like, you can kind of see where they're going. Okay, so as long as you sort of are clear on the method, the answer's going to show that you can kind of cheat, well, not cheat, but speed up by not working out yourself. So now let's put it all together. So our equation becomes the integral between, oh, I didn't leave myself much room. The integral between 0 and 1, sorry, 0 and pi over 4 of 1 over tan squared theta plus 1 squared times by sec squared d theta. Well, tan squared theta plus 1, if I look in my data booklet, this looks like a trig identity, Whenever you see a trig function squared, assume that you're going to be using some trig transformations. And we can see that 1 plus tan squared is equal to sec squared. So this inside the bracket is sec squared, so it's the integral between 0 and pi by 4 of 1 over sec squared squared, so that's sec to the 4 theta, times sec squared theta d theta. I can cancel 2 of the secs, so that makes it sec squared. And sec is 1 over cos. So this is 1 over cos squared, or the integral between 0 and pi by 4 of cos squared theta d theta. So that's part A, 4 marks. Part B, hence find the value. Now, whenever you see hence in standard and higher level, this means use the above. So we're actually being asked to solve this integral. Now, higher level students, make sure you know how to do this substitution or this identity. Whenever you see cos squared, we're going to use the fact that cos 2 theta is 2 cos squared theta minus 1. So cos squared theta is equal to a half cos 2 theta plus a half. Okay. So let's give myself a bit more room. So this means that we're actually solving the integral 0 pi by 4 of a half cos 2 theta plus a half. So now the half is going to be more straightforward. It's just going to become a half theta. Oh. The cos 2 theta, well, if it was cos theta, it would go to sine theta. Cos 2 theta, we divide by the derivative of the inside. If you're not happy with this shortcut method, go back and look at the substitution method that we use in standard level. But we can say quite quickly this is a quarter sine 2 theta. If you want to check, differentiate quarter sine 2 theta, and you'll get the exact same thing. So putting our values in, finally, we get a half sine pi over 2 plus pi over 8, subtract a quarter sine 0 plus 0. Well, that's 0. That's 0. Sine pi over 2 is 1. So the answer is going to be a quarter plus pi over 8.
I hope you enjoyed the video. If you did, be sure to click down here to like, subscribe, and share with a friend. If you'd like to access the full online course, including the notes pages we were making, there's a link in our description below. Thank you for watching and good luck with your revision.